Here we have question number 2 on our logs and exponentials test. It says describe the transformations from f of x equals 3 to the x to g of x equals negative 3 to the x minus 5 plus 1. So there's two functions here and we have to describe the transformations to get from this function to this function. Or in other words, what would happen to the picture or the graph or points on the graph when we change the function. So first we want to go back to our sort of general form of any transformation, and we always have our general form that looks like this. And the reason we do this is because it doesn't matter what our base function is. It doesn't matter if it's a quadratic or an exponential or a logarithm graph or a trig graph. We use the f as sort of our base function. F of x would be our base function. And then we know what each of these letters does. A, B, C, and D. So we just have to use this as our base function, 3 to the x, and take a look at g to the x to determine what a, b, c, and d are. So the first thing I notice is that there's this negative value in front, which is the same as negative 1. If I go to my general form here, that's clearly the a, that's in front. So a equals negative 1. B, there is no b value, so I'm going to go, b is always multiplied to the x, so we can see here that there's nothing multiplied to the x. C, though, is subtracted from the x, and we have c equals 5. So b equals 0, c equals 5, and, b doesn't equal 0, b equals 1, but it's basically ignored because 1 has no impact, and d equals 1, we can see at the end there, plus 1. Okay, so once we do that, then we just have to remember what a does. So a is a vertical stretch, so that we multiply a to all of our y values. Since it's negative, multiplying something by negative 1 doesn't change the size of it, so it doesn't stretch or compress it, but it will flip it, so it will reflect in the x-axis. This should be pretty intuitive. If you have a point whose y value is positive 2, multiplying it by negative 1 will make it negative 2, so it'll just flip in the x-axis. B is 1, so there's no impact here, no transformation. B would be the horizontal stretch or squeeze, though, we have to remember. C is 5, which means we're going to shift the graph 5 units right. If it would have been x plus 5 up here in the bracket, then we would have shifted it 5 units left. And lastly, D is our vertical shift. It's plus 1, so we're going to shift the graph 1 unit up. So if we can remember our general form here, what A, B, C, and D do, we can apply that to any function and explain what the transformations will be.